Welcome back to 4.1. So what is so special about inverse functions? Well, one of the things that makes them really special is if you take a function and plug it into its inverse, or vice versa, you only get x. And that's called the inverse function theorem. So basically what happens is, you remember composite functions, where we plug one function into another function? Well, if you take a function and you have an inverse, so say f and g are inverses. If you take a function and plug in its inverse for x, basically what happens is the function and the inverse function kind of cancel each other out, and all that you're left with is x. And if you do the reverse of that, if you take the inverse of the function, right, and you plug in the regular function, they also cancel each other out, and you just get x. So that's a really neat property of inverse functions. So let's look at an example so you can see what the heck I'm talking about. Remember we looked at y equals 3x plus 12? And we figured out in the last video that the inverse of that function was y equals 1 over third x minus 4. Do you remember we found that inverse in the last video? So let's call this one f, and let's call this one g, and let's see that they're inverses of each other. So what I'm going to do first is take f, and I'm going to plug in g. Okay? So I'm going to take the f function, and instead of writing an x, I'm going to plug in the g function. So here's f, y equals 1/3 x minus 4, and I'm going to take all of 3x plus 12 and plug it in for that x right there. And that's going to give me the following: 1/3, right, just that 1/3, and then instead of writing x, I'm going to write the entire g function, 3x plus 12, and then close my parenthesis, and then at the end I have a minus 4. So take a second to make sure you understand what I just did. I just took 3x plus 12 and plugged it into x to go do plugging g into f. Okay, let's simplify this a little bit. I can distribute my 1/3, and so 1/3 times 3x is just going to be regular old x, because a third cancels 3. And what's a third of 12? 1/3 times 12 is equal to 4. And I still have my minus 4 on the end. And look what happens now. 4 and negative 4 cancel, and we're just left with x, which is what we wanted. So when we plugged g into f, we were just ended up with x. And so let's see if it works the other way. Let's do g of f of x. Okay. So this time we're going to take g, and I'm going to take all of f and plug it into the x right there. All right, so starting with g, we have a 3. And then instead of writing x, I'm going to plug in f. Okay, so I'm going to plug in 1/3 x minus 4. So sorry, it's a little hard to see. So 1/3 x minus 4, I plugged in f for x. And then you'll notice at the end I have a plus 12, so I need to do that here, plus 12. This is kind of a separate thing we're doing here. All right, so let's see what happens. So let's distribute. 3 times a third x is just x. 3 times negative 4 is negative 12, thanks to the distributive property. And then on the end, I have plus 12. And what do you know? Negative 12 cancels 12, and I'm just left with x. So you can see that these two functions are inverses of each other, because when you plug one into the other, either way, you get x both times. So let's see what that looks like on this nonlinear function. Remember from the last video that we figured out the inverse was y equals the square root of x minus 3. And you'll remember we kind of had a positive or a negative version of that. It works for both, but for now I'm just going to look at the positive version. So let's call this f, and let's call this g. All right, so if we do f of g of x, I guess I'll use this notation because it's a little easier to understand. F of g of x. So we're going to take g and plug it into f. So here's f, here's g. So let's take g and plug it into f. So we're going to take all of g and plug it into that x right there. So we have a giant square root, and instead of x, I'm going to write all of g, which is x squared plus 3, because we just plugged that in for the x right there. And then you can see that I have a minus 3 on the end, like that. So that's how to plug g into f. And you can see what's going to happen. We have 3 and negative 3, which are going to cancel. So we have the square root of x squared. And what's the square root of x squared? That's right. It's just x. And that's what we wanted. And technically, the square root of x squared is the absolute value of x. But for our purposes, this is good enough. We'll talk more about absolute values and stuff when you get to calculus. So we won't worry about that for now. Let's try g of f of x. In fact, maybe you want to pause the video here and try to do it on your own. See if you can get it. Hopefully you got it. Let's see if you were right. We're going to take f and plug it into g. And so what that means is we're going to take the square root of x minus 3 and plug it in for the x right there. So the square root of x minus 3 is all being squared. That's that x squared. This entire f is being squared. And then you can see that for g, we have a plus 3 on the end. So that's g of f of x. So now let's see what happens. When we have the square of a square root, we know that the square cancels the square root. So that's going to equal x minus 3. And then we have plus 3. And if I have negative 3 and plus 3, these cancel. And sure enough, we just get x. So that's wonderful. That's really exciting. That's how you know. In fact, that's how you know you did it right. If I give you a function and you find the inverse, if you plug one into the other, that's how you know you got the problem right both times. So here's what we're going to do now. Let's do these last two examples really quickly, and then we'll. I'm going to do these a little faster since we've done a few examples already. So here we go. So what is we figured out that the inverse of 1 over x plus 3 last time was 1 over x minus 3. It was kind of similar. So let's call this f and this g, and let's plug one into the other. So what would f of g of x look like? Well, we're going to plug g into f, so I'm going to take this entire fraction and plug it into the x right there. That's going to give me 1 over x plus 3. Do you see how I did that? Do you see how g, 1 over x plus 3, became the entire x? So I had 1 over x plus 3, and then I have the minus 3 on the end. That's that minus 3 right there. So that's kind of confusing. We have a fraction in a fraction. So how are we going to deal with that? Well, it's copy.flip. Let me show you. If you have a fraction in a fraction, 1 divided by 1 over x plus 3, I could write that like this. 1 divided by 1 over x plus 3. Do you see that? That's 1 divided by 1 over x plus 3. And you know what to do with this. It's just copy.flip. This becomes 1 times x plus 3 over 1. Copy.flip. And 1 times that, that's just going to be x plus 3. So that's how you can deal with a fraction in a fraction. Just write it long ways, and then you can realize that it's copy.flip. So this whole thing right here becomes just x plus 3 minus 3 because of the minus 3 on the end. So all of this stuff became just x plus 3, 1 divided by x plus 3, and then the minus 3 was minus 3. So those cancel, and you get the x right there. Fantastic. Let's do it the other way now. G of f of x. Okay, we're going to take f and plug it into that number right there. So all of 1 over x minus 3 is going to get plugged into that x. So this is going to be 1 over, and this is going to be 1 over x minus 3. Okay, 1 over x minus 3, I just plugged into x right there. So it's 1 over x minus 3, and then the plus 3 is plus 3. And I know what I just did is a little confusing, but you will get the hang of it, I promise. So this 1 over x minus 3 was that x, and then the plus 3 is the plus 3. So we have negative 3 and 3, which cancel. So I get 1 over x, and I bet you can imagine what's going to happen next. It's copy dot flip, just like above, and so this is going to equal x. It's 1 divided by 1 over x, which is the same as 1 times x over 1, which just equals x. So 1 over x equals x. Try to do this last one on your own, and then I'll do it real quickly. Hopefully you paused the video and got the right answer. The inverse of this function was y equals x squared plus 2. And so let's do it. If this is f and this is g, it's going to be f of g of x. I'm going to do this pretty quick. That's going to be the square root of x minus 2, all of that being squared, plus 2. Square cancels the square root. We get x minus 2 plus 2, which equals x, just like we wanted. And let's go the other way, g of f of x. We do the square root. We take f and plug it into there, x squared plus 2, and then minus 2, just like that. 2 cancels with negative 2. We get the square root of x squared, which equals x. So hopefully you see that very interesting property of functions and their inverses. When you plug a function into its inverse or vice versa, both times you should get x. And now you've seen a bunch of different examples, so hopefully now you can do it on your homework. All right, next we're going to look at what inverses look like on a graph. See you there.